Welcome to my first video in this channel. For starters, this channel is dedicated to teach people more about data and how important is it in this world of technology. But first, I want to start with a simple machine learning model presented in the Kaggle.com website that's named the Titanic tutorial. Here we're going to learn how to understand data, how to process it, how to compile it, and how to engineer it. Here in Kaggle.com, if you just search for it, it's a very important website for the data scientist community. Here we have a lot of public data sets, a lot of notebooks with resolutions for different tasks, since face detection to NLP programs to anything that's related to it, machine learning or deep learning. You also can take micro courses here from machine learning, or to more specific stuff like a library in Python like pandas, or even Python or R or SQL. And here you also have competitions, which you can participate as a team or as an individual. There are a lot of them that are presented in Kaggle. Here you can see that Google has one for 150,000, American Express, Mayo Clinic. There's a lot of them that are presented here. But the first one that I want to show you guys and how to resolve it is the Titanic machine learning model. Basically here, Kaggle, if you go here to data, you can see we have two databases that present to us the train and the test. Here at the train we have 891 passengers with different feature sets that present to them either if they survived or not, and we are going to construct a model that will presenting this test database, presenting, for example, Mr. James Kelly. We are going to obtain, depending on his features, either if he survived or not, and with what accuracy. So to start, you can go. I will put the link in the description below, but I did this in a Jupyter notebook, the way I resolved it. But you also can just search for Google Collab. Here in Google Collab, it's very simple. It's also like Jupyter notebook. It's very simple as well to use. But I prefer Jupyter notebook. It's through the Anaconda navigator. It's not very difficult to obtain. Here, with the data that we have, or the databases, we have to understand the most important steps to how to adjust our data for the model. Here we have to take care of classification. We have to know what our samples are and the implications that they have in different classes, the correlations, how the different feature sets affect the final resolution. The conversion, we need to take care of our data in the same type of data, because we are going to have here like strings, not strings, but written word and categorical numbers and numerical features. We are going to have completion. There is going to be missing values in the determined feature sets, and we have to know how to complete them depending on the feature set. Correction, there's some training datasets that are going to be with inaccurate values or extra values that we are not going to have to need. Creation, we can create new features that are more effective for our model by the combination of different data feature sets, and charting how can we output the data in a visualization plot in order for us to understand it better. These are the imports from the different libraries that I executed, from pandas to NumPy to matplotlib to sklearn. If you already know anything about data, you have heard this about them already. second part is you need to upload the data. Here we're gonna have, you're gonna download it through here. It's very easy, and you're gonna put on the same directory. And here you're gonna have test and train is saved as an Excel because it's SCS. And you're gonna create a combination set that's gonna be between train and test. Here we can see the different feature sets that we're gonna have presented, since passenger ID, survive, bequest, name, sex, age, for many others. And our data set is presented in this manner, as we can see. Here we have categorical features, survive, sex, and embarked, as you can see. Ordinal features as bequest, continuous features as age, discrete features as SIPs and porch. But there's some problems, like the ticket feature set is a mix of numeric and alphanumeric data types. Name feature contains errors or typos, and cabin age and embark present a number of null values, and in the test data set cabin and age are incomplete as well. Here we can see that, for example, cabin is really little compared to all the other ones, and we have here the description of the different data types, since int64 to object to float. And here we can take already some conclusions, not really hard to understand for the first part. As we can see, we do count, mean, we do the standard deviation, the minimum, the quartiles, and here we can see that names are unique across the dataset because they don't repeat themselves a lot. 65% of the passengers are male. Cabin values have several duplicates across samples. Several passengers share the cabin. Embark takes 3 possible values. And export is the most used. There's a lot of things that we can analyze through here. Here we have to make some assumptions, meaning regarding the workflow goals that we set in the beginning. We have to complete the age feature sets. We have to complete the embark feature that's correlated with survival, very possibly. The corrections, we have to the ticket. There's a high, can be ignored because there's a high number of duplicates, and that's not good for a model. Cabin features are highly incomplete. It's really hard to try to complete it with the data that we already have, being that's 891 to 200 and something. It's very hard to interpolate all of them, so we can just drop it. Passenger ID can be dropped because it doesn't implicate the survival rate, and name can be dropped because it doesn't present contribution to the survival. However, we're going to see that the way that the name is just formed, as Mr., Mrs., it can be used for the final model. Creation, we can create a feature set named family. We can engineer a name feature set to extract the title as a new feature. We can create a new feature set to age bands in order to turn a continuous numerical feature into an ordinal one. We can create a fair range set for the same reason. Classification, we know already that women are more likely to have survived, so as children, and the upper class passengers. Here we can see for the first class 62% compared to 47.24. Female 74% survived, while male only almost 19. And we can confirm a lot of different things. Now we're gonna analyze the data by seeing the age bands and the survival rate. Here we see that infants had a high survival rate. Oldest passengers also survived, and a large number of 15 to 25 did not survive, as you can see here. And most passengers are in the range of 15 to 45 if we just put the two graphs together. We should consider age. Because of this, we should consider age in the model training. We complete the age feature, and we should band age groups. We have to correlate numerical and ordinal features. Here we just upon the classes that passengers are in, the survival rates. Here we can see that the class number 3 had the most passengers, but they did not survive, as we concluded before. Infant passengers in second class and 3 mostly survived, as you can see here. And most passengers in the first class survived. We can correlate categorical features, such as the embarked one, with sex. And here we can see that female passengers have much better survival rates than males. We can add sex features for the training model because of this, and we can complete and add the embark feature set for the training model because the interpolation is empty. Correlating categorical and numerical features is also possible. Here we can conclude that we should create a fair band feature. Next, we have to wrangle the data. This means we have to correct by dropping some features that we're not going to use, and create new feature extraction from existing feature set. Here we have different types of denominations for people. Most titles band age groups actually. As an example, master title age title means age of 5. And you can see here master male, normally a little guy. There's survival among title age bandits very slightly. We can make conclusions. Here we can see that master survived more. Miss as well, when Mr. and rare did not survive that much. Rare are distinguished as Dawn or Jonker or Major. It's not that common of a denomination. And here we convert a categorical feature. Here's sex to numerical, meaning female 1, male 0. Completion of the numerical continuous features. We estimate and complete the feature set with missing or new values, the age feature set. Here we could use the mean and median, which are we gonna use using median values for age across the sets of the classes and the gender combinations. And here we can deduct a lot of it. We can make the age band. We can know how much the percentage that survive between ages band. We can create new features combining existing features, the family size, and we can see what was the percentages of people with determined family size survived. We can create a new feature called is alone, and people that were alone most probably did not survive. And we can drop these ones in favor of this because the disparity here is a lot bigger. We have a family of 2 and 3 are literally the same. We can create an artificial feature combining age and class. Here we can see 1, 3, 2, 3. It's not very complicated, and we can complete a categorical feature. The embarks only accepts the door S, Q, and C. The training set presents 2 missing values, and we will fill this with the most common occurrence. With this, you can deduct that by the embarked C, 55% survived, and we can convert the embarked feature set by creating a numeric port feature, which is created. Here we complete and convert on the test feature set. We rearrange all of this, and with all of this rearrange and with the training of our data, we can model and predict and store the data. Here we're going to use the most simple models that are most commonly used, since logistic regression, KNN, SVM, and naive-Bayes classifier, decision tree, random forest, perceptron, and ANN, and RVM, or relevance vector machine. Here we're gonna drop the survived because we are not gonna need it, and we're gonna do this regressions. We're gonna fit the X train and the Y train, and we're gonna make spread. Here we're gonna account for 80% accuracy, and here we can measure the correlation. Here we see that it's not very good. These values, they do not exhibit good values, so we can test more types of learning methodologies, such as SVM, KNN, Gaussian naive-Bayes, perceptron, linear SVS, stochastic gradient descent, decision tree, random forest. Here we can see that decision tree and random forest are the better ones. They both exhibit the same level of accuracy, and because of it we will choose either one of them. You can also see that KNN also presents a good accuracy level, however a little bit less. Here we can see that all the scores compiled into each other, and by the end we can propose a submission, meaning by the passenger's ID we can derive if it survived or not. And with this we have a proper model. If you want later, you can commit it to an SCV in order to upload it into Kaggle and receive a note or a classification. And that's it. Hope you guys enjoyed the video, and see you later.